Next we can understand here abstract and overriding, overloading. So look at here, inheritance and polymorphism in Java. How we can extend from one class to another class. So there's the one extend keywords here we are having, okay, which help us to extend members and methods of the superclass. So if we can see this here, that public class subclass extend. So this extend keyword and then superclass name. We cannot give comma and give another name. No, only one class is uh, taken here. Java uses overriding and overloading to implement inheritance and polymorphism concept in OOPS. And multiple inheritance, Java is not supported multiple inheritance here. Okay. But this concept we can implement through the interface. So we have a concept of interface. We can make number of interfaces and then we can implement it. So there's a one keyword, implement keyword, which we use in implementing that. Next we have to understand the abstract class. What is abstract class? Abstract class can have abstract method or cannot. It may be having both. It's all possibilities there. But if once you are having abstract method, you have to make your class abstract. And as we know, abstract class cannot be instantiated. We cannot create an object of abstract class. Abstract class are public by default. Okay. Now interfaces contains constant values and declare only, means variable declarations or method declaration only. It is not having any code here. Are used to define behavior protocol. Okay. So can be implemented by any class anywhere in the hierarchy. So public interface name will help you to make interface, and let us say you are having class any name and implements interface name. So this is the one keyword, that is what implements, which help us to implement the interfaces. So you can write interface name comma, you can give other, so comma you can give multiple interfaces here. So you can implement multiple interfaces, but in the class you cannot extend more than one class there because multiple inheritance is not there. Again I am telling to you. Next is the abstract example. Here you can see this code. Now we are having here interface figure, interface 2D, which is extending figure 3D. So these all are the interface here. I have three interfaces here, right? Now here I have one method, here I have a method, here I have a method. These methods are not having any code, right? So these methods are by default abstract. In the interface you need not write abstract keyword. By default it is abstract, public abstract. Okay. Now if interface to interface, we have to use extend keyword here. Extend keyword. Class to class again extend, but class to interface we have to use implements, right? Now look at this abstract class name figure volume. It is having some variable, right? Int abc result equal to 0, and then abstract void volume. You have to write abstract here when you have abstract method in abstract class. Okay, and you can declare variable in the abstract class, but it is not necessary to initialize it. So you have seen this, I have not initialized ABC. But in the case of interface, if you are declaring a variable, you have to initialize. You have to initialize. So class, another class is the cube here, which is extending figure volume, implementing 2D and 3D. So now how many methods I have to write? One is here and 2D 3D. So one is again here and this is my third one. These all three methods I need to override here. So I have written 1, 2 and 3. This is my own method of this class and just displaying the masses. Okay. So even I'm not writing the code for 2D area, but it's still just opening and closing braces I'm giving here. I'm just writing the 3D area method. I'm just overriding the volume method here. So if you are implementing this abstract class and interface, you have to override all these methods. If you're not overriding, then this class also you have to make it abstract. Now you can see this code here. I'm just calling one creating class and then calling main method and then creating object cube c equal to new cube, and then we're calling all the methods here, right? Okay, so next we have to understand overriding. What is overriding? So it redefines, or we can say refers to redefining methods which have the same signature as the superclass in the subclass. Let us say you are having one method in the superclass and you are writing the code of the same method in the subclass. So what it is? It is the overriding. So are used to extend the function of the superclass method. Overriding equal to what? Re-implementing a method you inherited, right? So that could be the polymorphism. Now there's the overriding rules here. Like if you are overriding the method, it inherits a method from the superclass first of all. Superclass method is not final, should not be final. If it is final, you cannot inherit it. Means you cannot override it method. Superclass method is not final. So if it is private or final, you cannot use in the subclass. Superclass method should not be static, and that should not be also static. So you cannot override in these three cases. Superclass can be abstract. Just now we have seen in the 2D there is a one abstract method. In the cube we are overriding that method, right? Overridden method cannot be more restrictive. So if we are having the method in the subclass and the top one is a public, here I cannot make it private. The top one is default, I cannot make it some kind of private and protected. If it is default, okay, I can make it public, I can make it default, right? So call super if overridden. The return type must be the same as the original overridden methods. So return type should be same, and it could be different in the sense it could be the covariant returns. What is the covariant returns? Let us say I have one class. In the class I have a method, and that method is returning say animal. Return type is animal. Now I can write or override this method in the subclass, and I can say return type is the dog. And I have a class animal and there's a subclass is the dog. So it is a covariant. So dog is an animal type. So I can return dog here if my return type is there animal. So that is what covariant returns. Now the order and type of arguments of the overriding method should be identical to that of the superclass method. So you have to take care whenever overriding the methods in the subclass. If we can see this example, I have a class A and there's a constructor and there's a method void show system or repeat line. Again class B extending A. Again here one method is declared here void show. See. So what do you think? Here it is overridden method because already show is coming from the class A and we are writing again the show. So this is what overridden method here, and we are calling in the one another class having main method and creating object, and then we are saying new b and then dot show. So it will call the B class method here, it will not call the A class method. If you can see this example here, so here what we are doing, we are having a shape here, shape class which is abstract y, because here we are having one method, and that is a abstract void area. Okay, we are having abstract void area method. Now can I write body of area? Can you tell me what is the formula for finding area of shape class or for shape? Do you have any answer for this? No, because there is no such formula or some expression for finding the area for shape. But if I ask what is the formula of rectangle, you will say L into B. If I ask what is the area or formula for finding area of circle, you will say pi r square, right? You can reply these answers of my question, but you cannot reply here what is the area for shape. So in this case, I don't have any expression, I don't have any formula, so there is no body for this here, right? So in this case, what I have to do? I have to make it abstract. So I have abstract method, and then if I have abstract method, the class should be abstract. The class should be abstract. And this abstract class is having one more method, that is the this method. So abstract class can have only abstract method, can have this implemented method like this, or can be both. It is a mix up, right? Any cases of in this here it is possible. Next, if we talk about the class rectangle, extend shape. So we are extending shape. So area is coming from shape, area and disk, right? But again I am writing this area method here. What it mean? We are overriding area and writing the code here. Let us say L into B. I just written rectangle here. Now class circle extend shape. Again I am overriding the area method here and just writing result equal to circle. I can write here pi r square something, some expression I can write here, right? Now, so this is what overriding methods. The area is defined in the shape class and we are overriding in the rectangle, we are overriding the circle, right? Now, method overriding one class is there having main method, and that main method is located here having one object of rectangle r, and then we are saying r equal to new rectangle, and then we are calling r dot area, r dot disk. How we are calling r dot disk? The disk is not in the rectangle, right? Where it is? It is in the superclass, that is a shape, but I can call it because it is coming through the inheritance. Now circle C, new circle, C dot area, C dot disk. So I am calling the area and C, area and disk method from the circle. Good, that we can do. Then in this case, there is no need of creating shape. Look at this case now through the shape class reference. So we are doing here shape as equal to new rectangle. What we are doing, we are creating a reference of shape. But if you're writing here like let us say you're writing shape as equal to new shape, we cannot do this. This is wrong because shape is abstract class, and remember abstract class cannot be instantiated. We cannot create object for a abstract class, but we can create a reference. That reference is pointing to one rectangle. Rectangle is a type of shape. So now we are saying here rectangle is a shape. In this case we are saying rectangle is rectangle, circle is a circle, but here we are saying rectangle is a shape. So it is more real. And then we are calling ss dot area and ss dot disk. Now again we are doing sh equal to new circle. So now it is pointing to the circle now. If you can see the memory allocation, you are having one sh which is a shape type, and this is my hip where you are saying shape is new rectangle, right? So it is pointing to rectangle and working with rectangle. Now you are saying sh equal to new circle. So it is working with circle and pointing to circle, and this has become garbage. Dynamically it is resolving. So this sh guy first time calling to the method and functions and values, whatever it is in the rectangle, it is calling from rectangle, not is calling from the circle, right? So here it is calling again now, and this concept is called dynamic method dispatch. Dynamically it is resolving. So first I'm pointing rectangle, next circle, and then working with that, right? It's just like pointers, sometimes pointing some other memory and then pointing another memory, then pointing other memory, right? Okay, so we understood this concept here now. So this is the output. You can see this output here now. Now next is the overloading. Overloading is a technique in which more than one method having the same name exists in a program. The compiler differentiates between the same name method using the function signature. So the signature of a method consists of name of method, argument or number of arguments, return type, and the order of the arguments. This all comes in the signature, so we have to take care when we are overloading the methods. Okay. So look at these rules of overloading now. So overloaded method must change the argument list. It must have a different argument. Overloaded methods can change the return type. Overloaded methods can change the access modifier. So it could be some different modifiers. Overloaded methods can declare new or broader checker exceptions. So it can have more exceptions. Okay. A method can be overloaded in the same class or in the subclass also. So if you're writing, let us say one class having disk, another class you are writing disk, but you are passing arguments. So it is a overloading with subclass. Okay. So argument list is different here in the overloading, but in the overridden it is the same, right? If you can see this example here, I have a class overloaded, a overload demo test method is there, and there's another method test. So we are writing this method twice here, right? So here I have a no argument, here I have a one argument, right? Again here I have a two arguments. Again here I have another arguments with different arguments, different return type, right? Now we are calling here, so we are creating object and calling test, right? So it is returning different values and all. So this is what overloaded methods, test method, and this is called overloading, method overloading, which help us to implement polymorphism.